Set of exercises in electrochemistry. Part 1, Notation and Redox Balance. Exercise 1, balance the following redox reactions. As we know, we have two methods to balance the redox reactions. The first is the half reactions, and we have several steps to follow. Step 1 is to write the half reaction balanced. Step 2, when we need oxygen, we add H2O in both sides, and when we need hydrogen, we add H+. And step 3, the number of electrons gained should be equal to the number of electrons lost in the two-half reaction. And in step 4, we check that elements and charges are balanced. This is the method 1, which is the half reaction. The method 2 is the oxidation number, and also we have several steps to follow. 1, assign oxidation state of each element. 2, determine the elements oxidized and reduced. 3, determine the oxidation and reduction half reactions. The number of electrons lost should be equal to the number of electrons gained. If in the exercise they do not ask a specific method, we prefer to use the method of half reaction, which is easier. We pass to the balance of the redox reaction. Reaction 1, ClO3 minus plus Fe2 plus gives Cl minus and FeC plus. The half reactions are Fe2 plus to FeC plus. So to balance the charge, we add 1 electron. The second is ClO3 minus to Cl minus, and we need 3 oxygen. So we add 3 H2O. 3 H2O. In addition, we add 6 H+. Then we balance the charge, 1 minus and 6 plus. So we have 5 plus. Here we have 1 minus. So we have to add 6 electrons. The number of electrons gained should be equal to the number of electrons lost. So we multiply the first half reaction by 6, and we obtain the global reaction ClO3 minus plus 6 Fe2 plus 6 H plus gives Cl minus plus 6 FeC plus 3 H2O. We have 1 Cl, 1 Cl, 6 Fe, 6 Fe, 3 oxygen, 3 oxygen, 6 hydrogen, and 6 hydrogen. Then we balance the total charge, 1 minus, 2 plus, and 1 plus. So we have in total 2 plus, 1 minus, and 3 plus. So we have also 2 plus. So this reaction is well balanced. Reaction 2, CrO4 minus plus FeOH2 gives CrO2 minus plus FeOH3. The first half reaction is FeOH2 to FeOH3. Here we have 3 oxygen. So we need oxygen in the left side. We add H2O. We have 2 hydrogen and 2 hydrogens. So 4 hydrogens, 3 hydrogens. So we add 1 H+, then we balance the charges. 0 and 0 charge, and on the right we have 1 plus, so we add 1 electron. The second half reaction is CrO4 minus plus 4H to CrO2 minus. So we have 4 oxygen on the left and 2 oxygen on the right. So we add 2 H2O. Then we need 4 hydrogen, we add 4 H+, then we balance the charges, 2 minus and 4 plus. so 2 plus. Here we have minus, so we have to add 3 electrons. The number of electron gained equal number of electron lost, so we multiply by 3 and the reaction is balanced 1, 3, 1, 1, 1, 3. We balance the elements Cr, Cr for oxygen and 2 oxygen times 3, so 6 oxygen, so in total we have 10 oxygen and here 1 oxygen, so 11 oxygens. We have 9 oxygens and 2, so 11 oxygens. The hydrogens are also balanced. We count the charges of the reactant, 2 minus, 0, 1 plus, so in total 1 minus, and on the right side we have 1 minus, so the reaction is well balanced. We pass to reaction 3 MnO4 minus plus SO3 2 minus MnO2 and SO4 2 minus. By the same way, we write the have reactions SO3 2 minus to SO4 2 minus. We need oxygen, we add H2O, then we balance the hydrogens, 2 hydrogens, and the charges, we have to add 2 electrons. The second have reaction is MnO4 minus to MnO2. Here we have 4 oxygens, 2 oxygens on the right, so we need 2 oxygens, we add 2 H2O, then we add 4 H plus in the left, and we balance the charges, so 1 minus and 1 plus, neutral. Here is 1 minus 4 plus, so we have 3 plus, and on the right we have a neutral, so we have to add 3 electrons. The number of electron gained is equal to the number of electron lost. We multiply by 2 here and in the first by 3, and we obtain a balanced reaction. Reaction 4, by the same way, PbO2 Cl minus ClO minus PbOH3 minus. Write the have reaction Cl minus to ClO minus and balance the oxygen and hydrogen and add electrons in order to maintain the same charges on the left and the right. Then we have the second reaction PbO2 to PbOH3 minus. So we have 2 oxygen and here we have 3 oxygen, we add H2O, and we have 3 hydrogens, so we have 2 hydrogens, we add H plus. Then we balance the charges, 1 minus, here 1 plus, so we have to add 2 electrons. Number of electron gained equal number electron lost. It's not necessary here in this have reactions to multiply by a factor. So we add these 2 reactions in acidic medium, PbO2 plus Cl minus plus 2H2O give PbOH3 minus plus ClO minus plus H plus. In the exercise, they ask to balance it in basic medium. So to balance in basic medium, it's easier to balance in acidic medium than add OH minus to eliminate H plus. So we have to add OH minus to eliminate H plus, and we have OH minus here. H plus and OH minus will give H2O and will appear OH minus in the final basic reaction. PbO2 plus Cl minus plus H2O, because we simplify by H2O, plus OH minus give PbOH3 minus plus ClO minus. Reaction 5, by the same way, they have reactions CuI2 to Cu2 plus, so we have 2I and 4Cl. We have 2I, so we add, we have ICl2 minus, and we have 4 hydrogen, 4Cl minus, so 2ICl2 minus, and we add electrons to balance the charges. And cerium SO4 3 2 minus to cerium 3 plus and SO4 2 minus. We have 3SO4 minus 3, okay, and we have to balance the charges. We have 2 minus here, 3 plus and 6 minus, so 3 minus, so we have to add minus. Then number of electron lost equal number of electron gain, and we obtain the balanced reaction. Exercise reaction 6. I will balance this reaction by two methods, the method of Have equations and the method of oxidation number. I will start by the method of Have reactions, ClO minus to Cl minus. We need oxygen, we add H2O, we add 2H plus, then we balance by 2 electrons. CrO2 minus to CrO4 minus, we need 2 oxygen, we add 2 H2O, so we have 4 H plus, and we balance the charges by addition of 3 electrons. Number of electron gained equal number of electron lost. We multiply the first by 3 and the second by 2, and we obtain the global reaction. Reaction 7, osmium O4 plus H3ASO3 give OSO2 H3ASO4. The Have reaction H3ASO3 to H3ASO4. We have 1 oxygen. In addition, we add here H2O, so we have 2 H plus, and we balance the charges by 2 minus. Osmium O4 to osmium O2, so we need 2 oxygen. We add 2 H2O, 4 hydrogen, 4 H plus, and 4 electron to balance the charge. We multiply the first. We multiply the first by 2 and the second by 1, so the number of electron gained is equal to the number of electron lost, and we obtain the global reaction. I will balance reaction 6 by using the oxidation number method. The steps are the following. We have to find the oxidation state of all elements in the reaction. As we know, oxygen is always minus 2. So for Cl, X minus 2 equal minus 1. So X equal 2 minus 1. So for Cl, the oxidation state is a plus 1. CrO2 minus the oxidation state of oxygen is always minus 2. So X plus 2 times minus 2 equal minus 1. So X equal 4 minus 1. So X equal 3, and the oxidation state of chromium is 3. Oxygen minus 2. So for chromium, the oxidation state is X. X plus 4 times minus 2 equal minus 2. So X equal 8 minus 2. The oxidation state is a plus 6. And for Cl minus, the oxidation state of a monoatomic ion is equal to the charge of the ion, so the oxidation state is equal minus 1. Second, we determine the element oxidized and the element reduced, or we determine the oxidation and the reduction. So Cl, the oxidation state of Cl changed from plus 1 to minus 1. So we gain 2 electrons. Plus 1 minus 1. So we gain 2 electrons. From chromium 3 to chromium 6, we lose 3 electrons. The number of electron gained should be equal to the number of electron lost. So we have to multiply the chromium by 2 and the Cl by 3 and the chromium by 2. Then we balance the elements. We have 3Cl, 3Cl, 2Cr, 2Cr. We have 3 oxygen and 4 oxygen, so 7 oxygen. Here we have 8 oxygen. So we have to add in the left side, we have to add H2O. Then we have excess of 2 hydrogen. So on the right side, we add 2H+. So we obtain the same balance by the method of half reactions. We pass to the exercises of part 2, the electrochemical cell. Exercise 2. Explain why nitric acid attacks copper at room temperature, why sulfuric acid does not, and give the corresponding oxidation reduction reactions in both cases. So nitric acid dissociates to NO3- and H+, and nitric acid is a strong acid, so the dissociation is complete. And sulfuric acid can be considered as strong diacid, so it will dissociate to SO4- and to H+. So nitric acid and sulfuric acid, the ions involved in any reaction are NO3- and H+ if we use nitric acid, and SO4- and H+ if we use sulfuric acid. As we know that the reaction between oxidant and reductant takes place between the strongest ox and the strongest rat, or it takes place according to gamma rule. So we put on increasing scale of the potential E0, we put the value of E0 for the couples involved. What are the couples involved when we have H+? So we have H2, and E0 of H plus H2 is equal to 0, since this couple is the couple of reference at the standard state. And given that we have Cu2 plus Cu 0.34 and SO4 minus SO2 0.17 and NO3 minus NO 0.96 volt. As we know, when E0 increase, the strength of the oxidant increase and the strength of the reductant decrease. So in the family of these oxidants, NO3- is the strongest one, and in the reductant, NO is the weakest one. So we return to our reaction. We add nitric acid to copper. So we add NO3- and H+ to copper. We determine the species present. We have H+, we have NO3-, and we have Cu. NO3-, Cu, H+. H+ of nitric acid would not react with Cu since it's in the direction anti-gamma. But NO3- can react with Cu according to gamma rule. So between nitric acid and copper, we have reaction. If we add sulfuric acid, in other words, we add SO4 and H+. H+ would not react with copper since it's in the direction anti-gamma. And SO4- also would not react with Cu since the reaction is in the anti-gamma direction. So for this reason, the reaction takes place between the strongest oxidant and the strongest reductant according to gamma rule. So we have reaction between NO3- and Cu, and we don't have reaction between SO4 and Cu. NO3- react with copper according to the reaction. NO3- plus Cu gives NO3 minus plus Cu gives Cu2 plus NO. Then we balance this reaction according to the half reactions. So NO3 minus to NO, we have 3 electrons gained, and copper to copper2 plus, we have 2 electrons lost. So we multiply the first by 2 and the second by 3, and we obtain a balanced reaction. In order to check if our balance is correct, we count the charges 0, 2 minus, and 8 plus. So we have in total 6 plus, 3 times 2 plus, 0, 0. So we have on the right 6 plus, so the reaction is balanced. So nitric acid attacks copper at room temperature, while sulfuric acid did not. We pass to exercise 17.1. Consider the following zinc-copper cell. So this is a galvanic cell, and in the galvanic cell, we have to put 2 electrodes to determine the anode on the left, or the oxidation, the cathode on the right, or the reduction. The electrons flows from the anode to the cathode, and the current is in the opposite direction, and we have to put a salt bridge. So we pass to A. The current in the cell exit from copper electrode. This is true. The electron is in the opposite direction. The current is in the opposite direction of the electrons, so the current is from the cathode to the anode, so it flows from copper. So A is true. B flows from zinc electrode to copper. This is false. This is the direction of electrons. C has the same direction of electrons flow. This is false. They have opposite directions. And D, the current goes from minus to plus. This is false. Its direction is from plus to minus. The current is directed from the cathode to the anode. So the correct answer is A. 17.2, the electrons reaching the copper electrodes. The electrons are released from the anode to the cathode. So the electrons pass into solution. This is false. The electrons are captured by Cu metal. This is also false. The electrons have the directions as the current flow, and this is false. They have opposite direction. The electrons are captured by Cu2 plus ion. This is true. To note that on the left, in the left beaker, we have oxidation. So the reaction is zinc minus 2 electrons give zinc 2 plus. So the electrons are released from zinc. The electrons pass in the wire and are directed to the copper electrode. But on the right side, we have reduction. And the reduction, so Cu2 plus 2 electrons gives Cu. So the electrons are captured by Cu2 plus. The answer is D. Exercise 17.3, the zinc 2 plus ions capture electrons. This is false because in the left beaker we have, as we said, we have oxidation. So zinc minus 2 electrons gives zinc 2 plus. So zinc 2 plus is formed when zinc electrode release 2 electrons. So A is false. B, the zinc 2 plus ions are formed. This is true since zinc release 2 electrons and is transformed to zinc 2 plus. C, pass into the salt bridge. This is false. The salt bridge has a role to maintain the principle of electron neutrality in the left beaker and in the right. The zinc 2 plus ions get accumulated on the electrode, and this is false since they remain in solution. So the correct answer is B.